Hello, you're welcome to this video. If you're just seeing this channel for the first time, please kindly subscribe to my channel and share the links with your friends. Also, don't forget to click on the notification bell to receive notification anytime I upload a new video. In this video, we'll be discussing types of sets. The first one here is finite set. A set is said to be finite if its members or elements are countable. Take for instance, we have set A to be equals to 1, 2, 3, 4 and 5. Here set A has 5 members, and for that reason it is called a finite set. You could have another one, let's say set B to be A, E, I, O and U. Okay, so it has set B has 1, 2, 3, 4, 5 elements, so it's also finite set. So once you could count the number of elements in a given set, then the set is called finite set. Let's look into another one, infinite set. A set is said to be infinite if its members or elements are uncountable. Take for instance, you have set A to be equals to 1, 2, 3, 4, 5 and you have these 3 dots called ellipses there. So that means it continues in this pattern. So that means this is an infinite set. It could be like this, set B to be equals to 2, 4, 6, 8, then you have ellipses again. That means you continue in this pattern 10, 12, 14 and it does not end. So it is also an infinite set. So this is listed form of it. You could also have it in a descriptive form. Let's say set C, it will be equals to all even numbers. All even numbers. Set C is the set of even numbers. So here it will not stop because you don't know the last even number. So this is also an infinite set because the members cannot be counted. So that is the descriptive form of an infinite set. You can also have it in form of a set builder. Take for instance, if you say set D is equals to all the values of x such that x is a member of integers, that is Z for integers. Okay, so here it is an infinite set simply because nobody knows the last integer, so it continues forever and ever. So for that reason this is an infinite set. So sets A and B are infinite sets in listed form, while set C is an infinite set in descriptive form, while set D is an infinite set in a set builder form. So let's look into another type of set. We have singleton set or singleton. Okay, so a set is said to be a singleton if it has only one element. Take for instance, you have set A to be equals to 0 like this. So it has only one element, then it is called a singleton set. If you have set B to be equals to let's say 4, okay, it is called a singleton set. You have set C to be equals to A, so it is also referred to as a singleton set. Why? Simply because it has only one element. So the next one is an empty set. A set is said to be empty if it has no element. Okay, take for instance, you have set A to be equals to this. Okay, that means there is no element inside the curly brackets. That means set A is an empty set. So another way of representing an empty set is when you have set A to be equals to this sign here. So it tells us that set A is also an infinite set because it has no member. Okay, so these are the two ways you could show or tell that a given set is an infinite set. It's either you make use of this pair of curly brackets or you make use of this sign. Okay, so the next one will be equal sets. Two or more sets are said to be equal if they have the same members or elements. Take for instance, you have set A to be equals to 2, 4, 6 and 8, and you have another set B to be equals to 8, 2, 4 and 6. If you look at the members of sets A and B respectively, you see that they have the same members. So that means the two sets A and B are equal sets. So the next one will be equivalent set. So two or more sets are said to be equivalent if they have the same number of elements but different elements. Okay, take for instance, you have set A to be equals to 2, 4, 6 and 8, and you have set B to be equals to A, B, C, D. In set A, we have 4 members there, or 4 elements, 1, 2, 3 and 4. In set B, we have 4 elements there. We have 1, 2, 3 and 4. So since they have the same number of elements, then they are referred to as equivalent sets. The next one, which is the last type of sets we are going to look into, it will be universal set. So this is the set from which other sets are formed. It is denoted by this sign here, or you can make use of this sign, okay, to indicate that you have a universal set. Okay, so if I put this sign here, so it means that is my universal set. Okay, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so if I want to have other sets which are referred to as subsets, so we are still going to cover that in this lesson. Okay, so all the other subsets must be formed from this universal set. That is, I can have a set A to be 2, 4, 6, 8 and 10. I can never have 12 because it is not in the universal set. I can't put 11 here because it is not in the universal set. So I can have another set here, set B as 2, 3, 5 and 7. I can have another set C, and that will be 1, 3, 5, 7 and 9. So sets A, B and C are subsets of the universal set. Okay, so the universal set is a set from which other sets are formed. It contains all the elements, all the members of the other sets. So this will be the end of this video. In the next video, I will discuss set notations.